This presentation content has been created by Eclipse Security, LLC for Microsoft Corporation. For any questions or comments, please email inquiries@eclipsesecurityllc.com. The Security Code Review Level 200 presentation introduces the role that the Microsoft Security Development Lifecycle fulfills in trusted application development. It also provides an overview of the Security Code Review process, which is the manual inspection of application source code for security vulnerabilities. Examples of how to review code for common security vulnerabilities and security code review recommendations from the Microsoft SDL are also presented. Addressing the subject matter will enable our organization to enhance our application development practices and the security of our applications. Please note that it is recommended that the presentations addressing the following topics be addressed prior to this presentation. Those presentations are buffer overflows, SQL injection, and cross-site scripting. In this presentation, we will complete an overview of the Microsoft SDL, the security code review process, security code review examples addressing buffer overflow, SQL injection, and cross-site scripting concerns, and security code review recommendations prescribed by the Microsoft SDL. The Microsoft SDL is a holistic and comprehensive approach that leverages education, process, technology, and executive commitment to consistently create more secure software internally within and external of Microsoft. Since 2004, all internal Microsoft developers have been required to adhere to the SDL, and Microsoft has updated the SDL every 6 months to address any emerging threats since its inception. True to its name, the SDL was created to complement rather than disrupt the software development lifecycle. The core phases and principles of the SDL include the training phase, the requirements phase, the design phase, the implementation phase, the verification phase, the release phase, and finally the response phase. In the training phase, every Microsoft developer must complete mandatory security training focusing on secure application development practices. Training sessions include topics such as threat modeling, secure development and testing practices, and security for application development managers. In the requirement phase, requirements for security and privacy must accompany functional requirements of the software that's being created. Such requirements may include the use of encryption, authentication, and other security measures based on the business requirements, exposure, and sensitive data. To that end, a security and privacy risk analysis is performed at this stage. In addition, the threshold for security and privacy, or bug bar, is defined during this phase to ensure that bugs with certain severity are addressed and resolved before the software is officially released. For the design phase, eradicating coding bugs with security implications is not sufficient. Design vulnerabilities can have a substantial detrimental impact on security and are much more difficult to address during the verification phase. To that end, threat modeling is a critical SDL requirement and a Microsoft security innovation that is recognized by analysts as the next evolution in creating more secure software. Through threat modeling, architects and developers at Microsoft are able to approach security in a structured and methodical way from an attacker's perspective. This allows Microsoft to identify and reduce attack surface and mitigate the risk of potential security design issues. The implementation phase is the application code development phase where code is written by developers using industry best practices and analyzed with both internal and external tools, such as static code analyzers and special security debuggers, to help ensure that those best practices are being followed. Requirements are also specified by the SDL in this phase to ensure that applications are built using the latest compiler versions and built-in compiler protection features. The verification phase is the quality assurance phase within which rigorous security testing is conducted in addition to typical functional testing procedures. In the release phase, the final security review is the major milestone that a Microsoft product team must pass in order to release a product under the SDL. During this meeting, security experts and the development team review all of the activities mitigations, and security artifacts that are relevant to the project in order to ensure that the security quality requirements are satisfied. During this phase, the product team defines a response plan describing procedures, accountabilities, and contact information in case security vulnerabilities are discovered after the product is operational and used by the customers. In the response phase, after an application is released, the Microsoft Security Response Center, or MSRC, handles any security issues that are uncovered in the wild and mobilizes product teams within Microsoft to provide timely fixes for security issues. In summary, secure software development requires executive commitment, ongoing process improvement, education and training from VPs to product managers to developers to testers, tools to aid in detecting security vulnerabilities, and incentives and consequences to ensure everyone adheres to the SDL process. As was previously indicated, this presentation focuses on security code review and how it can be used to complement other security assessment activities as prescribed by the Microsoft SDL. With respect to specific phases of the Microsoft SDL, this presentation focuses on the implementation and verification phases. Building safer and more trusted applications that can better withstand attack from today's threat landscape requires strong security strategy. One highly effective method that should be part of almost every security regimen is the security code review process. Security code review involves the manual inspection of an application to identify security vulnerabilities at the code level. Security code reviews are best conducted when an application is nearing a stable state and the possibility of future code changes are minimal. This is recommended so as to minimize the amount of wasted efforts that application development teams will have to expend reviewing code that will significantly change. It is in part for this reason why security code reviews are conducted towards the final stages of the Microsoft SDL verification phase, called the security push. More about this important phase will be discussed later in this presentation. Oftentimes, security code reviews are performed solely by security analysts. However, given the size and complexity of modern applications, security testing should ideally be performed by developers, testers, and security analysts. Application team developers and testers provide familiarity with the application's design and implementation that can aid in identifying vulnerabilities that may be contrary to the overall intended functionality. Security analysts can perform security code review efforts that are free from assumptions and previously established biases in order to help identify vulnerabilities that are outside the overall intended functionality of the application. Lastly, the insights gleaned by Microsoft, which are incorporated in its SDL, and more specifically in this presentation focusing on security code review, are being shared with each of you as a way for our organization to enhance our application development best practices and the security of our applications. If you are new to the concept of security code review, the easiest way to conceptualize this security assessment process is to imagine the role of a publication editor. When an author submits written text, such as a book, news article, or white paper for publication, an editor will review that text prior to release. This is to ensure that the final publication is of the highest possible quality. As part of the editorial process, each line of the text is reviewed for errors, such as grammatical errors, inappropriate language usage, and other aspects that might affect the overall quality of the text. Feedback from the editors is provided back to the authors, and they amend the text as necessary. In the same fashion that an editor will review written text for errors, developers, testers, and security analysts review application code for vulnerabilities that could negatively affect the quality of the application ultimately being delivered to the customers. Vulnerabilities such as buffer overflows, SQL injection, and cross-site scripting are flagged by review teams and addressed by developers prior to releasing the application. With the availability of automated code analysis tools such as Microsoft FXCop and Microsoft Prefast, which can scale and analyze code much faster than human reviewers, a question that you may have is, are manual security code reviews really necessary? Any assessment method, including the use of code analysis tools, has specific strengths and weaknesses. In the case of code analysis tools, certain vulnerabilities may be easily detected while other types of vulnerabilities are difficult to detect. There may be a gap between risks that are detectable by code analysis tools and actual risks present. No one assessment method by itself is sufficient to comprehensively assess the security posture of an application. This is why the Microsoft SDL implements a variety of different assessment methods at various stages throughout the software development lifecycle to help development teams deliver applications that are safer and more trustworthy. To illustrate this point, let's look at a demonstration of a code vulnerability that is difficult for code analysis tools to detect, but easily detectable through conducting a security code review. In this demonstration, you will see some sample code that contains two buffer overflow vulnerabilities. One of the vulnerabilities will be detectable by code analysis tools, and the other will not be. This demonstration is meant to show the importance of implementing both security code review and code analysis tools, and not to use one as a replacement for the other. Let's begin and view the sample code. This file is a sample C application that has two functions defined in addition to the main entry point tmain. Both of these functions can be exploited in some way to support a buffer overflow attack. However, only one of these buffer overflows is detectable by standard code analysis tools, while the other is not. This function, named buffer overflow strcpy, contains a standard buffer overflow using the strcpy function. It allocates a fixed length character buffer on the stack and tries to write data passed in by the str argument into the static buffer. This second function, called copy buffer, that performs essentially the same function as the strcpy function. It takes a destination buffer argument named dest and a source buffer argument named source and copies the contents of source into dest using a while loop. It makes the incorrect assumption that the contents of source is null terminated and that the size of source will fit within the boundaries of dest. If a caller is not careful when calling this function, a buffer overflow attack may be possible. Let's now run code analysis tools against the sample code and see what happens. Notice how the code analysis tool has detected the buffer overflow and buffer overflow strcpy function, but not the one in the copy buffer function. If the caller of copy buffer is not careful to ensure that source is null terminated and that the size of source fits within the boundaries of dest, then a buffer overflow attack is possible through this function. This reinforces the notion that code analysis tools cannot replace security code review, and vice versa. Both are important components in every application development team's security strategy and should not be used as a replacement for the other. Security code reviews, like any other risk assessment method, has several pros and cons. One key advantage of security code reviews is that a deeper analysis is possible than that which is possible with other security assessment methods. Since the code is entirely visible to the reviewer, the need to make certain assumptions that other methods may apply is reduced, and thus the number of false positives and false negatives are also reduced. Reviewers can also draw upon their personal experiences and expertise in certain technologies that may be difficult for automated methods to emulate.